All right, so if you looked at the part 1 of my videos, I did the first 2 tables over here to determine whether or not they were functions or they weren't, linear or exponential. So now we're going to work on these two. One of the things that I pointed out in the last video was if an exponential graph, when you're doing the exponential equations, that you don't multiply your starting value or your initial value with that growth factor. So we're going to take a look at this next one. Again, as you can see, the x coordinates, whatever they may be, or whatever we're talking about in this particular problem, still going up by 1 every single time here. So then we look at this. We go from 12 all the way up to 972, which is a pretty substantial change in value between them. You can see that it slowly is getting bigger and bigger. So we know that this can't be a linear graph because linear graphs would be changing by the same amount. And there's definitely not happening. So my next thought is immediately going to exponential. Do I have an exponential function in front of me because this is multiplying by a specific number every single time? Now, for many of you, it would be really easy for you to say, all right, I'm going from 12 to 36, which is a multiplication of 3. If that happens and you're not sure of the number that it is multiplying by, which in this case it is times 3, one trick that you can do is if you take, this is all consistently going up by 1, so what you can do is you can take like the last number if you want, divided by the number previous to it. So if I do the multiplication, I'm going to use this. This is a great calculator, by the way. If you do need this for like your ASVAB test, this is the calculator that they use. So if you are interested in that, it is built into the program. So if I take the 972, oops, it would help if I turn it on, 972, and then I divide that by our previous number that you see here, 324, this is another way you can get your growth factor, and it's 3. If it's consistent, it's going to work in every single one of them. So 324, I divide that by the 108, also going to get 3. So all of these are multiplications of 3. So we do times 3 on all of them. So that is our growth factor in this case. So we're going to start off with f of x. That's our function of x. And we're going to take a look. Where are we starting at? Well, here's the funny thing. This doesn't have a starting value of 0. We're going to have to go work our way backwards. So we're going to go back 1, and that's going to be at 0. And then we have to work our way back here. So this is times 3. What we're going to do is the opposite of times 3, which is to divide by 3. So we take 12, we're going to divide by 3, and we get 4. So that ends up being a growth factor of 3 with a starting value of 4. So 4 times our growth factor of 3, and then to the x power. And that would be how you do your exponential function. If you would like more questions like these, you can find them on my YouTube channel at YouWantAlgebra, and you can find this located in the exponential function section. Also, don't forget to like, share, and follow for more on Instagram and TikTok at the same name, YouWantAlgebra. Thanks so much.